Hey and welcome to our tutorial. Today we will continue with drawing shapes inside Microsoft Word using Visual Basic for applications and using the polar coordinates. What we will cover today is what's called a superellipse. Now I've already created a few videos about the superellipse, being this one superellipse using VBA, where I draw the superellipse using the Bezier curve. I've already used this ellipse in the how to create Instagram logo in Microsoft Word tutorial. So if you haven't seen those videos, please go check them out, but this time I will actually use what's the real equation for superellipse. It could be found on Wikipedia if you search for superellipse, but we will not start from scratch. We will start from our older video, for example this one, which is used for drawing those gauges, or sorry, those badges and blobs. So let's delete everything and let's see how the code looks like. So if I open the macros for drawing those, I will edit the macro. You can see I have the segment, which is number of segments, number of parts from which this shape will be drawn. I'm using the segments to set the size of the polypoints array, which is used to store all the points. Then I have the radius, angle, and the origin. I'm setting the origin to some random values, and then inside the loop I'm incrementing the angle in here. I have to convert this angle from the degrees to radians, to not go from 0 to 360 degrees, but instead to go from 0 to 2 pi. Then I set the radius as some static value plus cosine function, and I convert everything from the polar coordinate system to Cartesian coordinate system. So let's talk very briefly about the polar coordinates and Cartesian coordinates. So usually when we draw something inside Microsoft Word or in any other application, we think about a point as being sorry, this is not looking very nice. So being the point on the x and y value. What we can do instead is we can set the origin point, for example, in here being 0 and 0 degrees, and we can think of any point as being at some distance from the origin point, being the r as a radius, and some angle being the angle theta. Now we cannot tell Word to draw a point on this position being the r and theta. We have to first convert it back to the Cartesian coordinate system, that is to x and y value, and we do it simply by setting the x equals cosine theta times the radius, and the y equals sine the angle theta times the radius. So this way we can calculate the r and the theta any way we want and convert it to x and y value and then draw it. Now if we set the r radius to be same for all degrees, each degree, if we plot it, if we increase the degree, we will get a circle around the origin. Actually, let's try to update our macro to draw a simple circle. Let's just delete all this extra stuff to draw those badges. So let's just set the radius to a static number like 100. So if I run this macro, I'm just getting a circle, nothing special here. Now I want this to be like a superellipse, which is just a fancy name for a shape which is, it has too many, possibilities, but it's well known for, if you raise the number high enough, this n exponent, you will get a shape which is something in between a circle and a square. It's very similar to like a rounded square, but it has kind of a natural feel to it. So before even taking a look at the equation, let's try if we can somehow think about how something like this could be done. So we will open the macro again. What we will do is we will not touch the radius at all. We will just keep it 100 or any other value all the time. We will just change the equations to calculate the x and y position, and I'm having this in an opposite way. I'm using the sine for the x. I can as well use how it should be, like cosine for x and sine for y. It's not a big difference. That just sets where the first point is being drawn. So I have a radius which is very same for converting the polar coordinates to Cartesian coordinates or for drawing the circle. What I have to do is I have to somehow change the cosine and the sine value, and I will do it by raising it to some value. So I will say I want this cosine angle to be raised to some value, so raised to, for example, value of 2, and I will do it for both the x and y. So I want both to be raised to some number, to number of 2. If I run this, something should happen, and that something is, I'm not setting the line. I should set the line and not the fill. So I will set the line and make the line visible because it will not be filled for now. I will also set the line weight so I can see something. I will probably set the fill to visible to no fill, to not visible. Okay, so if I run this, I'm getting something. I'm getting some kind of shape, but it's obviously very far away from a superellipse shape. What's going on is there are two things. First thing is previously we were getting the cosine to be between -1 and 1. If we raise it to 2, we only get positive numbers. The second thing is we would like to raise this to a number smaller than 1 as well. So if we raise it to, like, for example, 0.8, you will see we will get this error because we cannot raise it. We cannot raise a negative value to 0.8. So what we have to start with is probably we have to take this value and make it an absolute value, so it will always be a positive number. So if I do it like this, I will set the absolute value for both sine and cosine version of the angle. I will delete this one, and if I run this again, I should get something which resembles part of the superellipse. So this kind of looks like a superellipse, but we only have like a 1/4 of the shape. We only have the shape if we imagine that there is the... Where is my pencil? Okay, so if we imagine that there is the origin point in here, this is the x and this is the y-x. It goes like this, so there is a positive to the right and to the bottom. So in here everything is positive, and that's where we draw actually the shape. In here the x is negative, but we are not getting any negative values as well as for the y. That's because first thing we've set this to be absolute value, so it's always positive, and when we raise it, it's always positive as well. So we need to somehow make sure that what we were getting previously as for the negative or positive values, it will get preserved. So we want to set, if the cosine angle previously was a negative value, then this entire section will be negative as well. And we will do it by simply multiplying it and using a function called sine, which will give us a sine of the number. So it will give us -1 for negative numbers and +1 or +1 for positive numbers. So if I do this only for the x, you should see, if I run this script, you should see that I will also get negative x values. So I should have also this part of shape. So if I delete everything and run this macro again, hopefully we will get half of the circle. So the only thing missing is actually making sure that the y value gets the sine as well. So I'll again say times the sine function of the sine angle. And now I should get like a full circle, full superellipse. Now if I open the Wikipedia again and look for the equation, which is probably down here, you will see that what we got is actually what's on the Wikipedia. So we are getting the absolute value of the cosine and sine function, and then we set the negative or positive value based on the sine function. The only difference is that the exponent is used 2 divided by n, so that's actually what we can do. We will raise it to a value of 2 divided by something, for example 3. And just changing the second number will give us different results. As if we increase this to a higher number, we will get closer to the actual square like this. If we make it smaller, we will get closer to the circle. So if I get it like 2 divided by 3, it will be closer to the circle. I believe that 1 will be just a circle. Now this is like a circle, nothing more. And if we keep decreasing the number, like 2 divided by 1, that should be a diamond shape. And anything below 1 will give us like a kind of star shape. So if I set this to be 2 divided by 0.8, we will get this kind of star shape or whatever we call it. If I keep increasing this the number, it will go more towards the center. And that's basically it. That's all that's needed to draw a full, right or true superellipse shape inside Microsoft Word using the equation. So not using the Bezier curve, but using the real equation, which is most likely what's used to draw those shapes in, like for example iPhone icons or so. If you take a quick look at the Wikipedia, You can also see there are some few variations. For example, you can set the exponent to be different for x and y axis, so you will get those different shapes if that's what you are looking for. Up here you can also see that what we've shown, that you will toggle between the star-like shape to a shape which resembles a square. It's actually named squircle, or how it's pronounced, I'm not quite sure. And that's it. Thanks for watching.